Rightio, back we are with the second video on infrared spectroscopy. Just a reminder that infrared spectroscopy allows you to identify the presence or absence of organic functional groups. So in this video we're going to look a bit more specifically at what you look at on an infrared reading on the spectra that's produced. I do want to remind you, and I'm just going to quickly whip up here and show you, that you do get a resource sheet. So you don't have to remember any of these numbers, and it does give you a bit more information there, as you can see. Okay, so let's start with the basics. So here I have a spectra, and the first thing that I do want to identify is this peak here that I've drawn in. So this peak here is between 2,850 and 3,000 for its wave number, and it is due to the presence of a C to H stretch. Okay, now the stretching is the way that this bond moves in order to absorb the infrared radiation. So this one is a peak that is always here. You always find this. So it's actually not one that I want us to concentrate on discussing, because all organic compounds contain CH and therefore this peak. What I do want to use it to illustrate is the way that we interpret these graphs and how we talk about it. So I'm going to use a little acronym I've called PLAT. Now, I'm not fond of acronyms because it just gives you something else to remember, but I'm just going to draw my little plait there. That's your hair being plaited. But in this case, I'm going to try it. So the P stands for peak. So the first thing we have to do is identify the peak. So in this case, we've identified the peak. So there is a peak at between 2,850 and 3,000. I would call this a strong peak, as it goes from the top right down to the bottom. That's all I need to say. So there is a strong peak at 2,850 to 3,000. The next thing I need to do is I need to link this peak to something in the structure. So what I would say there is my peak at 2,850 to 3,000 is due to a C to H stretch. So I'm linking the peak, which was at 2,850, to something in the structure, in this case, a C to H. Third one, these two go together. So now we need to analyze and interpret. Okay, so that basically, what does this mean? What does this tell us? Now for this particular one, not much. So our analysis of this is that since all of our organic molecules, so there's our peak, there's our link, all organic molecules contain C to H. So that really doesn't tell us much. Okay, so that's my analysis and my interpretation. And then my last one that I've put here, you know, sometimes you just have to make a word, but we do need to tie it all together. Now, this step often can't happen until you've got more than one piece of evidence, okay, but it is important. It's the answer. It's what does all of the evidence mean together, okay? So identify the peak clearly. Tell us what that links to, what part of the structure. Analyze, what does this mean? Tie it all together. Okay, so here is our first introduction to how to interpret an infrared spectra. And I'm just going to put one more in this video, and I'm going to look at these two here. You'll notice that I've just shortened the spectra because I just want to look at one peak here. So in the left-hand one here, this here is my C to H peak that I identified in the last part of the video, the last spectra. So here, this is a broad peak, and I'm going to go down here and say that's at about 3,400. Okay, so my P here, I have a broad and reasonably strong, as it's long, peak at 3,000, around 3,400 wave number. Okay, so that's my identification. Right, part 2, link. What does this tell us? Now, if we go up to our resource sheet, what that tells us, and this is the one I always look for first, so as soon as I see a spectra, is there this big, broad peak right up here around 3,500? That links to the presence of an OH group. Okay, so there's my link. If I have a broad, strong peak at around 3,400, this links to the presence of an OH group in the molecule. Okay, so A and I, what does this tell me? This tells me that this molecule, the thing that made these peaks, contains an OH group. Therefore, it's either an alcohol or a carboxylic acid. You can see straight away you need to know your functional groups. Okay, we can't do the T yet because we haven't got any more information. But peak, linked to a group, analyse and interpret, what does this mean? Okay, so big broad peak up the top, OH, first thing to look for. Quick sneaky look, because these aren't quite so common, but while we're in that area of the spectra, so again we're up around between 3,000 and 4,000, look for this. This can be medium, it can be strong, so this one is probably hard to tell, so we'll go medium to strong. And what we're looking at there is kind of between, if we look down here, what have we got here? 3,300 to 3,600, something like that. Okay, so my P is a medium strong peak at 3,300 to 3,600. Remembering that this is the C to H again, it's always there. Sometimes looks a bit different, okay, but it's always there. Okay, so here's my P. What does this one link to? Go back to my resource sheet. In fact, I'm going to show you that there, and this is an amine here. Okay, it's on my sheet. So this links to the presence of an amine group or an NH2. Okay, so if I have this medium strong, and one thing I've forgotten to say here, this is a doublet peak. Very, very clearly there are two parts to that peak there, two peaks in one. And that also is indicative of an amine. Okay, so doublet, amine, NH2. Analyse that. Our molecule must, if we have this, be an amine or an amide, which also has the NH2. Okay, so let's just go over that again. The plat is one thing to take out of this video. The other one is this huge peak for an alcohol and this doublet peak for an amine, both right up between 3,000 and 4,000 on the spectra.